So let's see question number 26. So they are saying in this question, ethanol can be used to make propane nitrile. Remember, this is the nitrile group, C triple bond N. And the rule for the naming of nitrile, we calculate all these three carbon atoms. So it's a propane nitrile in two steps. What types of reactions are X and Y? What we are observing in this reaction X, it's an ethanol and it is converted into an ethyl bromide or halogenoalkane, I would say, bromoethane. So what we are observing in it, actually OH group is substituted by bromide group. Hmm? So we can see it's a nucleophilic substitution reaction. So it's not a free radical reaction, X. And in next case, what we are observing, this Br group is substituted by nitrile group. So it is again a nucleophilic substitution reaction. I think we discussed this one in the previous lesson, right? Okay, sorry, we were on question number 27. We did that. How many esters? Number 28, this one. Have the molecular formula C4H8 and O2. Actually, we have to draw to find out the esters. So let's see how many different esters with this molecular formula means having four carbon atoms. So I can have this group coming from an acid and combining with one carbon coming from an alcohol. So that one ester is possible, which is methyl propanoate. And another possible ester could be this one, the two carbons coming from an acid and two carbons from an alkyl group, ethyl ethanoate. And another possibility is this, one carbon coming from an acid and three carbons from an alkyl group, right? So most probably this could be B, but here we can have another alcohol possible. I have taken this alcohol in which OH group is attached with the carbon 1. So it's primary alcohol. But with the same number of carbon atoms, I can have secondary alcohol as well. So if secondary alcohol combine with an acid, so this ester is also possible, isn't it? So total possible uh, esters with four carbon atoms are four. Clear? So by drawing all these possible esters, we can find out the number of esters which are possible with this molecular formula. Three first carbon, three from acid, one from alcohol, two from acid, two from alcohol, one from acid, three from alcohol. But here, alcohols can be primary or secondary, right? Or tertiary as well. But here we have only three, so only two possibles, primary and secondary. So that's how we can find out the number of possible isomers. Okay, after this, let's see another one. Number 29. What they are saying in this question, they are saying carbon monoxide, carbon Nitrogen dioxide and sulfur dioxide are atmospheric pollutants. So, which reaction occurs in the atmosphere? So, if we go through that chapter of air and atmosphere, we have this reaction. Let's see, first of all, number one, A. They're saying carbon monoxide is spontaneously oxidized to carbon dioxide. So, actually, carbon monoxide does not oxidize spontaneously to carbon dioxide in atmosphere under normal conditions. They're saying next NO2 is reduced to NO by sulfur dioxide. Okay, yes, this reaction is occurring in atmosphere. This NO2 that reacts with sulfur dioxide and convert it into sulfur dioxide and NO. And then this NO which is produced that is again oxidized by oxygen and gives NO2 again back. So that means in this reaction, NO2 is acting as a catalyst. And this is also known as homogeneous catalysis. Homogeneous catalysis means in which the reactants and the catalyst they are in the same physical state. So yes, we can say that B is correct. Next, they are saying NO2 is reduced by N to NO by carbon monoxide. No, carbon monoxide does not reduce this NO2. Sulfur dioxide is oxidized to sulfur trioxide. No, we have seen that sulfur dioxide is oxidized by NO2 in the air. So the correct option is B. Okay, let's see another question. Number 30. Now, in this question, they are saying oct-1-ene, that is oct-1-ene can be thermally cracked. So to solve these type of, first of all, I have to write down the structure CH3, then CH2, five times CH2, 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 3, 4, and 5 times CH2, and then comes CH, and then double bond, and then CH2. So that is oct-1-ene, 8 carbon atoms. So we know that what happens in cracking. Remember, cracking gives us which type of products? Alkanes, or can be cracked into either alkane or alkene, and sometimes hydrogen as well, right? So they are saying which of the four compounds W, X, Y, and Z can be obtained by thermally cracking this oct-1-ene. Okay, let's see W. That is ethene. So if we break this compound from this point, so yes, it will give us an alkene that is possible CH2 double bond CH2, right? And if we break this compound, it's propene. So that is also possible if we break it from here. That can give us propene as well. So instead of this, the other possibility that can give us propene as well. Yes. Okay. Next is CH3, CH2, and CH3. That is propane. So if we break it from this point, it can give us this alkene and the another one alkane. That is also possible. Remember when we break long chain alkanes, so give one alkene and another alkane. So if we break from this point, so that can give us either alkene of three carbon atoms or alkane of three carbon atoms. So this one is also possible. Next, this compound Z that is having 1, 2, 3, and 4 carbon atoms. So if it breaks 1, 2, 3, and 4 carbon atoms from this point, is that possible? Yes. The another compound which will break and gives us CH double bond CH2, CH and CH2. So this fraction is also possible. No doubt others are also possible, but all these four are possible. It means W, X, Y, and Z, they are possible, right? They can be obtained by thermal decomposition of this compound. Now, let's see next question. They are saying in this question, structural isomerism and stereoisomerism should be taken into account. So both the isomerisms. When answering this question, they are saying how many isomeric alkenes with this formula C5 and H8 are present in the mixture produced when 1,4-dibromopentane. Okay, so 1, 2, 3, 4, and 5. It's a pentane with the two bromine groups at position 1 and 1, 2, 3, and at position 4. And they are treating it with sodium hydroxide in ethanol. Remember the reaction of halogenoalkane with sodium hydroxide. If it is an aqueous and sodium hydroxide reaction in presence of an ethanol, there are two types of reactions. Clear? If we treat it with aqueous, then it gives SN reaction, nucleophilic substitution reaction. But when we treat with sodium hydroxide in presence of ethanol, then it gives elimination reaction. Elimination reaction means it will give us an alkene. So if one of the bromine that is eliminated, so hydrogen from carbon 2 will eliminate and it will give us carbon double bond carbon here. And similarly, 3, 4, and 5. This bromine can eliminate. Now, if this bromine eliminate, it can make either double bond with the carbon 3 or with the carbon 5. It means we can get two types of compounds. Let's see, it makes a bond with carbon 3 and 4, and another possible, here only one possibility, the double bond between carbon 1 and 2, and the next one is this. Clear? So it means this compound is possible, this compound is possible, but that is the difference in these two, that is they are position isomers, right? Is it clear? But when we talk about these two structures, they are saying consider stereoisomerism. Is there any compound which can show stereoisomerism? So we can see here this carbon has hydrogen atoms, oh sorry, two hydrogen atoms here. So if the carbon is bonded with similar groups, so that cannot show the stereoisomerism. Remember, the double bond, they can show cis-trans isomerism. And the condition for that, if they have different groups attached with them, they can show cis and trans. But if they have similar groups attached with them, they will not show the stereoisomerism, cis-trans isomerism. So here we have double bonds. No, that cannot show. Here having both hydrogen atoms, this cannot show. But what about this one? This carbon is having one hydrogen and one methyl. And this carbon is bonded with hydrogen and this another group. So it means this can also show the stereoisomerism, cis and trans. So how? Look at this. C double bond C, hydrogen here, methyl group here, hydrogen here, and this whole group. CH double bond CH2. So it's a cis structure. And its trans is also possible. CH3, H, H, and CH double bond CH2. Is it clear? So the one structure, this, two, actually we can consider this one as cis and trans, and the third possible structure is this. So how many compounds are possible? So the answer is three, right? Okay. Now the next question, that is the presence of a halogen. Sorry. Hmm. Question number 32. They're saying the presence of a halogen in organic compound may be detected by warming the organic compound with aqueous silver nitrate. So remember when we treat aqueous silver nitrate, so in that case, this water behave as a nucleophile and it actually substitute the halo group which are present here. So we can see in these compounds the CF bond, CCl bond, and CI bond. So if you remember the reactivity of these halogenoalkanes, that depends on the bond energy, CF, CCl, CBr, and CI. So CI has the lowest bond energy. It means this bond is the weakest among them. And this bond is strong, having high bond energy. So the one which is weakest, that will break first. So in these examples, we can see this one will break first. And when iodide is there in the solution after the breakdown of this bond, it will combine with silver ion and gives us yellow precipitate of silver iodide. So that means this C will give us the quickest precipitates, yellow precipitates in this compound because of the lowest bond energy in case of this Ci, right? Okay, let's see another question. In this question, they are saying 17.6 gram of pentane 1-ol is completely combusted. So the structure, first of all, pentane 1-ol. So 1, 2, 3, 4, and 5. It's a pentane, and there is OH group. The rest are hydrogens, right? So how many carbon atoms? There are 5 carbon atoms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 hydrogen atoms and 1 oxygen atom in this. And when it burns, it gives us carbon dioxide and water. Okay, they are saying which volume of gaseous products is formed when measured at STP. So we have to remember one thing. There is RTP. RTP stands for room temperature and pressure. So when we say room temperature, that means 25 degrees Celsius. But sometimes we use STP, that is standard temperature and pressure, right? And when we say standard temperature, so that means 0 degrees Celsius, right? And the pressure, standard temperature, so you can see there is a difference in pressure. So definitely the volume of 1 mole of a gas, that will also be different. So when we take this 25 degrees Celsius, the volume is 24 dm cube for 1 mole of a gas. Clear? And when we take 0 degrees Celsius, so definitely it's a lower temperature. So at this temperature, 1 mole of a gas, it occupies 22.4 dm cube. That is molar volume of a gas for 1 mole of gas. Clear? So now let's calculate from this information. They have given us 17.6 gram of this compound. So 17.6 gram, let's find out its molar mass first. So 12 into 5, that is 60. There are 12 hydrogen atoms. So 1 oxygen atom. So the total is 88. And 17.6 means how many moles we are using. So 17.6 over 88. You have a calculator. So how many moles we are getting? Yes. 0
Zero
point?
point 0.2.
Yes. So it means we are using 0.2 moles of this pentane 1-ol. And now let's balance this equation. 5 carbon atoms, so we will have 5 carbon atoms here. How many hydrogens? 12 on the left side, so let's place 6 here. And we can balance how many oxygen atoms are there. So 5 2s are 10 here and 6, so total 16. So what if I place 7.5 here? 15 and 1 16, because oxygen is in excess, so we can balance it like this. Now from our balanced equation, under these conditions, 0 degrees Celsius, so the water will exist. Does it exist as a gas? No. Hold for a second, I'll be back. So we were calculating this. So 0.2 moles will produce how many moles? So this wouldn't be in gas form at this temperature. So the only thing in gas form will be carbon oxide. So here we have the molar ratio 1 and 5. So if we have 1 moles of this and 5 moles of CO2, so using 0.2 moles will give how many moles of carbon dioxide? Yes.
One.
Hmm. So it will give us 1 mole. So 1 mole will occupy how much volume? 22.4 TMQ. So the answer in this case is A, right? Okay,
Mm-hmm.
now next question. Question number 34. In this question, they are saying crothyl alcohol with this molecular formula is a colorless liquid which is used as a solvent, reacts separately with bromine with the oxidizing agent potassium dichromate and KMNO4 and PCl5. So here, look at this CH3, CH double bond CH, and then CH2 and OH. So if we treat it with bromine, so which type of reaction it takes place at room conditions? So that will give addition reaction because of this double bond. And after addition, what we get? We get Br here and Br here. So that is also used for identification of double bond. So this product is not obtained in it. So that's why option A is incorrect. Now the next one, they are saying reacting with potassium dichromate, heat under reflux. So what is the role of it? It is actually oxidizing agent. So what oxidizing agent will do? That will oxidize this alcohol into carboxylic acid. So if it is oxidized into carboxylic acid, so what product we are expecting? So we are expecting this product. But here they have given us an aldehyde. So that means it does not stop at aldehyde. Alcohols oxidize into aldehyde and then aldehyde oxidized into carboxylic acid because we are heating under reflux. So if it vaporizes, it comes back into the uh, flask. So that's why the final product is carboxylic acid. So option B is incorrect. And if we treat it with this KMNO4, so that will give us carboxylic acid. It is again oxidizing agent. But remember one thing, when we oxidize this alcohol with KMNO4 and heat it under reflux, it means it's concentrated and heat. So what happens? This OH group will oxidize to carboxylic acid, C double bond O and OH. But under these conditions, concentration and heat, this double bond will also break. So we get two products, CH3, C double bond O and OH, and this carbon will also oxidized. So we get this one, right? So it means option C is also incorrect. And remember the reaction of alcohols with PCl5. So what happens in that reaction? This OH group that is substituted by chlorine. So this product at room temperature, that is correct one. Clear? So option D is correct. Now, the next one in question number 35. Skeleton formula of these compounds they are given. So we can see this one is ketone and this one is tertiary alcohol, right? Which
Mhm.
reagents can be used to distinguish these two compounds?